Hello and welcome. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today we're going to be kicking off our second series on using machine learning for beginners, and we're going to be exploring the Titanic Survivor dataset. Now, for those who haven't heard of this dataset before, this is a Kaggle dataset that was assembled, and it basically has all the survivors of the Titanic and their attributes as far as what age they were, what sex they were, what kind of ticket they bought, and a whole bunch of other information. So we're going to be exploring that data set, doing some pre-processing, some analysis of the data, and then we're going to be feeding it to machine learning models in order to make our predictions on whether individuals survived the Titanic or they did not. So without further ado, let's go ahead and jump over to the Jupyter Notebook and get started looking at the data. All right, in our notebook, you can see in the very top, I have the link to download the dataset. Now, you can either type this right in, or you can just go to Kaggle and type in Titanic. It is one of their more common datasets, so you shouldn't have any problem finding it. Go ahead and download those. They'll give you three files: the training file, the testing file, and an example output. We're going to be focusing on just the training and the testing datasets. I also included a graphic of what all of the different features mean. You can get this straight from Kaggle as well. And for now, I won't go through this. I'll wait until we actually import our data, and then we'll step through each of the features to see what they represent. So let's start by importing some packages. We're going to be importing pandas. We're also going to be importing NumPy. And lastly, we're going to be importing PyPlot. Okay, so if you haven't heard of any of these packages or you don't have any experience with them, I do have tutorials on all three of those. I will link them right now, and you can go ahead and check those out. But for everyone else, let's go ahead and keep pressing. So the first thing we're going to need to do is we are going to need to import those two data sets that I was talking about. We're going to use pandas to do that. So I'm going to be calling these train_pd for the pandas data frame. And we'll do pd.read CSV. And since I have the data sets inside of the folder where this notebook is, I am just going to pass the name of the CSV file. Okay, that takes care of the training file. We're going to copy that. We're going to do the same exact thing for the testing file. And I will go ahead and just display the training data frame so we can see that it was imported. Okay, you can see here's our training data frame, and it has all our different features. Now, the difference between the training data frame and the testing data frame is the training data frame has this survived column. So it has the ground truth on whether this specific passenger survived or died in the Titanic. So we will go ahead and just run through the other features, I guess. Passenger ID, every single passenger is assigned a unique ID. In this case, for the training data set, that goes up to 891. And the testing set obviously has different IDs within there. We just talked about survived. So if you go to the graphic up top, in the survived column, it tells you that a 1 is yes, they survived the Titanic, and a 0 is no, they did not. So useful information to remember. The class, so again, coming up to the top, we have what ticket class the ticket belongs in. So the person may have bought a first class ticket, second class ticket, or third class ticket, and that's represented by an integer value for each of those. Next, we have the name of the passenger. Typically, all of these are last name, comma, title, first name, middle name, and sometimes they'll have like nicknames or something like that associated with it as well. Next column is the sex column, male or female. Age column, this is a floating point of the age. SIB-SP, if we go up here, you can see SIB-SP is number of siblings and number of spouses on board. So we can see if the passenger was traveling with any siblings or spouses. And the next column, P-arch, that is the number of parents and the number of children on board. So again, two columns that tells if the passenger was traveling alone or not. And it could be useful for predicting whether or not they survived. Next column, ticket, what their ticket number was. Now, this isn't super helpful, but it does show whether or not somebody bought a bunch of tickets. So, for instance, if a family of 4 was traveling and they bought all their tickets together, they're going to have the same ticket number. And so we can get a count of how many tickets have the same number and maybe use that. Additionally, for the next column, the fare column, this is going to be the fare for all of the tickets that were purchased with that number. So if more than one ticket was purchased, we're going to have to adjust the fare to represent what an individual ticket cost. And let's see, the last two columns, so cabin, this is which cabin they were staying in. Now, there are different decks on the Titanic, and the letter before the cabin number refers to which deck they were on. Last one is the embarked column. Coming up to the top, you can see 3 different places where they embarked from, and those are represented by 3 characters, C, Q, and S. So lots of useful information here. Let's go ahead and start looking at the data and pre-processing it a little. Now, like I said, the training data set, the only difference is that survival column. So let's go ahead and save that as a separate variable. And we're going to call that survived. And that's just going to be equal to the train PD at survived. Okay, so we're just extracting that column. And the reason to do that is I want the training and testing data sets to look identical so that we can combine them. And so I'm going to just drop that column from the training data frame now that we have it stored as a separate variable. So to do that, I'm going to use the drop function. So take the data frame dot drop. Drop is looking for whatever column. So in this case, it's the survived column. And it also wants to know which axis. Now, columns are axis equals 1, so I will pass that in there. And that will, let me display it. And that will just drop that column from the data frame. And you can see survived column is no longer there. Okay, let's continue. So another unique thing that we're going to need to know is we have the people who survived, but we also need to know which of the passenger IDs are associated with those survival rates so that we don't get them confused after we try to split our data in the end. So we need to know all of the passenger IDs for the training and the testing sets. So let's go ahead and extract both of those. I'm going to call this train index, and that would be equal to the train PD at the passenger ID. And I'm going to do the same exact thing to extract the test indices. Spell it right. Okay, now we have all the passenger IDs for the training and the testing sets so that we can split them out after. And we should be good to go ahead and combine these data frames. We are going to do that. First, I'm going to call this combine PD. And we're going to do that by using the concat function. So that is pd.concat. We're going to pass it in the 2 data frames. So train PD and test PD. Now, when we do this, the index is going to stay the same for each of the data frames. So it's going to go 0 to 890 and then 0 to however long the test data set is. And we want to reset that. So it just goes 0 to the number of passengers. And we can use the reset index function to do that, reset underscore index. And now when you reset the index, it's going to save the original index by default to a different column, unless we pass in drop equals true. And this way it just cleans up the data set and we only have to manage one index column. Okay, let me go ahead and just display that, show you what we did. Okay, as you can see, we are up to 1,309 rows now because we combined the two. Our index goes from 0 to 1308. And we just have all of the data in one place now. Okay. Now, one thing you're going to notice is there's a whole bunch of these NaN variables, and that just means that there was no number there. So NaN means not a number for those not familiar with pandas or NumPy lingo. And so we're going to need to correct for all of those missing values. So let's go ahead and first just let me print a title here. I just want to know how many values are missing for each column. To do that, we will go ahead and print the combined data frame dot is null. So is null is going to look through the entire data frame and it's going to return a true if it has a null value or a missing value. And I just want to take the sums of all of the different columns. So that's what this line is doing right here. Go ahead and run that. And you can see we have our column names, our feature names, and we have how many missing values are in each of those. So age has 263, fair has 1, cabin has 1014, and embarked has 2. So we are going to have to take care of these. And so that is the first step that we're going to do, is figuring out how to fill in or what to fill in those missing values with. First thing we are going to do is start with age. And we're just going to work our way down the list. So I'm going to define a new variable called y. It's going to be the combined data frame at the age. Okay, and I want to know how many, I want to know the distribution of the ages that were filled in. So I want to know how many of each different age there are within the data set. So to do that, you can do value counts. And that's just going to return the age as the index, and it's going to return how many of those ages are in the data set. I'm also going to do an x variable, and that is just going to be the y.index, and I need to do dot values to get that in the list. So again, this is the x values will be what the actual ages were. The y values will be the count of those individual ages. And the reason I'm doing this is because I'm just going to plot it so that we can see what each of them look like. So passing in plt.figure, I'm going to change the fixed size, just make it a little larger, making it 10 by 10. And we are going to plot these as bar charts. So again, passing in the x and the y values that we just created. I'm just going to create a quick title here. This is going to be all ages, and plt.show. Okay, so we are going to be plotting the ages on the x-axis and the number of people within those ages on the y. Go ahead and show it. Fig size, I forgot my equal sign here. Make sure you put that equal sign. And you can see here's our chart. Now it's a little skewed to the left. As you can see, it's got this tail going to the right. And the majority of the ages are somewhere between 20 and 40, I'd say. And then there's obviously some outliers, and fewer people are towards the 80-year-old mark. So this is great. Now you could fill all the ages with like the median of all of these ages and hit somewhere in the middle. Instead, I want to find if we can maybe make it a little more specific to our individual passengers. So I have a feeling that whatever class the ticket was probably has different ages associated with it. And I want to say probably first class has more older people, and the lower classes maybe has more of the younger people. So let's go ahead and just see if I'm right on that. So I'm going to say I'm going to make a new variable called class age. And that is going to be equal to the combined data frame. And now I only want the class. Make sure, nope, I did not spell it right. So it's a capital P and then lowercase class. So I want the class column and I want the age column. Okay, so what is that doing? Well, it's just taking this data frame and it's stripping out the class column and it's stripping out the age column and removing everything else. Now I want to take for each I in range 1, 2, 4. Okay, so this is just giving me values 1, 2, and 3. That's essentially what it's doing. Let me just add some space here. I am going to be basically taking all of this right here. So copy all of this pyplot code. We're going to keep the figure size. Now the title is going to be changed to the let's call it class, and then we will add the string of I. So this is just going to print whatever class that we're looking at. I'm going to just move this bar down a little bit. Okay, so now we have to get our values kind of like we did before. So we're going to have y values, and that is going to be equal to the class age, that data frame that we just created. And that I want to know when the class age at p class is equal to whatever our I value was. Okay, so this is taking this data frame up here, and it's just filtering out everything that is equal to whatever class we're looking at. And again, those are classes 1, 2, and 3. And then once I do that, I want to extract whatever the ages were. And then I want to do a value counts. So this is going, filtering out the classes to be equal to whatever class we're looking at, taking the ages, and then doing the same thing we did before, just looking at the distribution of all the ages within this class. X is going to again be equal to y.index.values. We are going to be creating the bar chart of X and Y and then showing it. So this should give us an idea of what each of the classes look like for age distributions. So class 1, you can see it's kind of centered actually. It looks fairly good distribution. Class 2, a little more to the left, a little younger. I kind of figured that was going to happen. And class 3, way younger. So there is some value here. Rather than just taking the median of the ages, we're going to go ahead and take the median of each of these classes, just so it's a little more specific to our passenger. So I next want to know what those medians are for each of the classes. So I'm going to make a new variable median. That's going to be class age dot group by. So this is going to group by the P class. So it's going to group all the classes together. And now I want to take the median value of each of those groupings. And I will go ahead and print medians. And you can see there are our median ages for each of our classes. First class median is 39, and then obviously it keeps going lower down to 29 and 24 for the remaining two. And that is what we're going to use to fill in our missing values. Now, to do that, we need to go through our data frame, figure out when the age equals 1, when the class equals 1 and the age is missing, we need to import this and do that for all the other classes. So let's go ahead and do that. So for I in range 3, we are going to be looking for an index value. So idx equals np.where. That's supposed to be an n. Okay, np.where. I want to know where the combined PD at P class equals. Sorry, I'm just realizing up here in my for loop, I did not type I. So this should be for I in range 3. I want to know when the class is equal to I plus 1. So this is going to give me the entire data frame where the class equals 1. But I don't want to just know that. I want to know also where the age is null. So that would be combined underscore PD at age dot is null. And let's close out some parentheses here. Okay, I think that should be good. Okay, so this is saying, again, it's finding all the indices where the class is equal to whatever class we're looking at. So let's start with 1, where the class is equal to 1 and the age is missing. And I want to just get the first set of indices. Now we are going to pass that in to combined PD using the dot locate function. We're going to pass in those indices. Also, we want to say we're going to pass in the indices, which is going to give us the row, but I only want the age column. So I'm going to do a comma and then say age as my other column. And I'm going to say that is equal to medians dot values at whatever class at 0. All right, a lot of code here. So let's break this down again. Finding the indices where the age is missing for the specific class. We are taking those indices for the age column and we are putting in the median values that we just got up here. let's go ahead and display combined PD. Okay, now if I go to the top where I printed it out, you can see this age column, line 1304, 1307, 1308, all have missing values. And you can see those were filled in. So the third class, it took the median age of 24, put it in there. Actually, all these were third class. If we displayed the whole data frame, you'd see the other ones were filled in as well. Okay, so that should have taken care of all of the missing age values. And now we can continue on. So the next one that was there was, we had, I think, one missing fare. And so I just want to print that one row that was missing. And that's going to be combined PD at fare. Combined PD at combined PD at the fare. So I want to take all of the rows. I want to figure out when the fare is null. Let me just make sure I closed all my brackets here. Yep. All right. So this is just going to show me that one empty null. And you can see this was the class was equal to 3. You can see ticket number. And you can see where they embarked from. So I have a feeling, for the most part, if you embarked from the same location and you had the same class of ticket, you probably had a close fare cost. So we are going to take both of those and just say, okay, find me the median of the same class and same embark location. To that, I'm going to make a variable called simfares for similar fares. That is going to be equal to combined PD at, and it's going to be similar to what we did before. So where the combined PD at P class, and in this case, I am not going to make it flexible just because I know exactly what this class is. I'm going to say I want to know where the class is equal to 3. And I want to know where combined PD at embarked is equal to S, just like the one down here. And okay, so again, this is taking where the class is 3, the embarked is S, and now I just want to know all of the different fares that are out there. So just pull out the fare column. And I'm going to print, this is going to be the median. So I'm going to take simfares.median, and this is going to give me the median value that I'll be importing in there, which is equal to $8.05. If I want to see just the distribution of all of them, I can just maybe do a histogram, simfares, and you can see, yeah, that's about where all of it is. There are obviously some outliers over here, and again, that may be because we haven't corrected for the number of tickets that were purchased. So if maybe these guys bought 6 tickets or something like that, and that's why the cost is way out here. But for the most part, you can see it's a fairly solid distribution, and 805 is probably pretty close. All right, so now we need to just replace that value. So combine PD at fare, and we're going to do a dot fill NA. So this is going to just take all of the missing values, which in this case is just 1, and it's going to fill it with that value that we just calculated. So we're going to fill it with simfares.median. And since I'm not saying the data frame is equal to all of this, I need to pass in place equals true. This is just saying take the combined, do this function, and replace it, instead of saying combined PD at fare equals combined PD at fare.fill. It just makes it a little nicer to code. And that will go ahead and take care of our missing value for fare. All right, a couple more that we have to do. Next one, Embarked. I think this it has 3 maybe that we're missing. I can go back up and look. I'm going to skip cabin for now. We'll go back to that. It has 2 that are missing. Let's just knock this one out. Okay, so similar to what we did up top, actually I can probably just take all of the same code. So just copy this code down. We're going to say, I want to know the embarked. I want to know where the embarked is missing. I'm going to change this to similar embarked. Actually, before I do any of this, let me just go ahead and display this. Okay, so embarked location, missing for 2 of these. Now, kind of like the other one, if their fare is the same and their class of ticket is the same, then it's probably a good indication that they embarked from the same spot. And so that's what we're going to do. So from here, instead of p class equals 3, this is p class equals 1 to match both of these. I want to know where I want to just look around to see where the fare is, let's say greater than equal to 70. And then I want to kind of do the same thing. And I want to know where the fare was less than or equal to 90. All right, so what is this doing? Well, it's taking all of the classes equal to 1s, and it's saying, I want to know when the class is equal to 1 and the fare is between $70 and $90 to kind of hit this fare in the center. I want to know what those embarked locations were. Making sure I filled everything here. And I did. Let us just go ahead and print those similar embarked locations. So you can see a bunch of values in here. Not necessarily what we want. I want to know. Let's go ahead and get rid of this. I want to kind of do the same thing. Now I just want to actually, get rid of all of this again. I want to say print the simemb.value counts. So this is just going to print me the value counts for each of the 3 different characters, C, S, and Q. And it's just going to show me which ones are in each of them. This is simemb. So you can see, all right, so 29 of those people in that specific category embarked from C, 25 from S, and 3 from Q. So I'm just going to take the highest one, C. It'll be quick enough. I mean, these 2 are close, so you can maybe fine-tune your fares to see if you can get something closer, but I'm just going to stick with whatever the higher one is. And to do that, we are going to take the combined PD at embarked, and we are going to fill that with C. And again, in place equals true. So this is just taking these 2 missing variables and filling them with C because that is our highest one over here. Run that, and we should be good to go. Now, the last one is the ticket. The cabin. The cabin had 1,014 missing values in it. And so for all of the missing values, I'm not going to try to fill in all of them because that is a lot of missing values. So I'm actually just going to create another cabin variable, we'll call it. So I want to say the data frame at cabin. I want to fill NA. And I'm just going to say, I'm going to call it M for missing. And then obviously I need in place equals true. All right, so this is taking all the missing values for the cabin and is just filling them with the variable called M. Now I want to take, I don't really care what the cabin number is, but I do care what this first letter is because that is going to say which floor of the Titanic they were on, which deck they were on. So in this case up here, this is the B deck. So I just want to take the very first character from the cabin. So that is going to be equal to combined PD at cabin. And that is going to, we're going to just reassign all the values to be combined PD at cabin dot string at 0, taking the first character from the string for each of these and just replacing the entire cabin column with that. So we can go ahead and just print what that looks like. I'm going to print the cabin column, and then I'm going to do a value counts, just so we can see how many are on each of the different floors and what the different floors are. All right. You can see there's our 1014 that are missing, but there are some other variables here, like the A deck, there were 22 people on there, B deck 65. Now on the Titanic, the lower the letter, so A is all the way on the top, and then it works all the way down to G. Now this T, I'm not really sure what this T is, and there's only one of them. So what's going to happen is if this T is in the training set, it's just going to overfit and say, well, if I see the T, then we're just going to automatically predict whatever the answer was. If it's in the testing set, it's never going to have seen it before, so it's just going to ignore it. And I want to kind of just avoid that by replacing this T value with missing. We're just going to say that, okay, this T wasn't a typo maybe, and we're going to replace it with M. To do that, we need to find the index of wherever that one was. So that's going to be using np.where. We're going to say, I want to know where combined PD at cabin is equal to T. And I want the first set of indices. And then combined PD.locate, I'm just going to locate whatever that indice is. And we're going to, take the indice, and I'm going to say the cabin column. And we're going to say that is equal to M. All right, so finding the T index, passing it into the data frame, and changing it to an M. And run. Okay, so that has taken care of all of our missing values. Let me jump down here, display combined PD. And then we're also going to print combined PD.isNull.sum. All right, so the sum of all the missing values like we did before, they should all be 0 now if we filled it in correctly. Here's a data frame. I don't see any missing values here. And you can see going through each of the features, we don't have any missing values. So that is the first step in a lot of the data science process, is pre-processing data by figuring out what to do with missing values. Now, some algorithms can handle missing values, but if you have a lot of them, or if your algorithm can't handle them, then you have to go through and figure out what to do with them, either dropping the rows or filling them in like we did with the median value, or maybe using the mean value or some other value that you can come up with. But you may need to, and you probably will a lot of the time, need to figure out how to fill those in, or you just need to straight up drop them out of it. If we try to drop them out of it from here, again, we only have 1308, 1,309 rows, and 1,014 of them were missing just for the cabin alone. So we would be dropping the majority of our data. So that's just not an acceptable approach to handling missing data for this. We could just drop the cabin column, and that may be something that you would want to do, but the cabin column also does have a lot of useful information for the other ones that are filled in. So this was just a quick approach to how to fill in the missing data. I'm going to stop here, and in the next video, we're going to start pre-processing the data a little bit more, and we're going to be looking at how to maybe group some of these or split up the name column so it gives us useful information and get it ready to be fed into our machine learning model. So stay tuned for that. Thanks for joining. If you got anything out of this, like the video and subscribe to the channel to see the rest of the series and other series that we do. Thanks.